Welcome to qnawire.
This question says, for the reaction A to B, a reaction vessel initially contains only A at pressure 1.32 atmospheres, and at equilibrium, the partial pressure of A is 0.25 atmospheres. And then it asks us to calculate the value of Kp, or the equilibrium constant with respect to P. And the equation we need to find the equilibrium constant is the partial pressure of B, or the products, raised to the power of B, which is the number or term in front of the compound, and divided by the partial pressure of A, or the reactants, also raised to the term in front of the compound. And so we have the partial pressure of A at equilibrium, it's 0.25 atmospheres, but we don't know the partial pressure of B. We need to solve for that. And we were given the initial and equilibrium pressures of A, so we can fill out this ice table to figure out what the partial pressure of B is at equilibrium. So I is initial, 1.32 A, 0 B, C is the change, and E is the equilibrium. So we can calculate the change between 1.32 and 0.25. That's negative 1.07 atmospheres. We're losing 1.07 atmospheres of partial pressure from A. We're going to be gaining some amount of pressure for B. Now we have to consider the ratio of B to A. There are twice as many B molecules as there are A in this reaction. So we're going to double this term. So if we're losing 1.07 atmospheres of the reactants, we're gaining 2.14 atmospheres of the products. And if it's changing and started at 0, then the equilibrium will also be 2.14 atmospheres. Great, so now we have the equilibrium partial pressures of the reactants and the products. We can plug them in and solve for the equilibrium constant. So the partial pressure of B is 2.14 atmospheres. And the exponent B is the term in front of B, which is a 2. So we're going to square this. And we're going to divide it by the partial pressure of A at equilibrium, which is 0.25. We'll raise it to A, but there is no term in front here. It'd be a 1, so we're not going to raise it to anything. And if you solve this, you would get an answer of about 18. And so this is the equilibrium constant with respect to pressure of this reaction, given the values